Hi everyone, and I'm sorry for the last day. There was some connectivity issue, and it got dropped, and I couldn't reconnect it back. Right. So you got enough time to go through the collection concepts. You guys got any questions for me before I get started?
Hi Arun, when I try to initialize the array list, it says array list is raw type, reference to generic, some warning is giving the IDE.
The warning was, did you specify uh, within the angular bracket? Did you try to specify the data type?
No.
Okay, that's the problem. So you will see the warning. Even if you might have observed the examples which I demonstrated for you, right? It was on day 12. If you look at this, there was a list demo program. You see the warnings, right? Same. Array
Yeah.
list is a raw type and reference to generic type. So this is some, see, understand, I'll tell you what is the reason for it. Normally, you are the one, when you start using your array list, you normally use array list for storing what? Similar type of items only.
Okay.
See, normally what you do, normally what you have, you have a collection of employees, or maybe a collection of strings, maybe a collection of integers, or maybe a collection of IDs. Mostly you'll have what? You'll have collection of similar type only, right? Since you have a collection of similar type, so what is recommended is whenever you try to create array list, it is asking you to specify the type. See, there is another program called restricted array list demo, and you don't see a single warning here. Whereas in the list demo program, you see a warning because I didn't specify the type. I'm not restricting the array list to one particular type. Whereas in the restricted list, I'm restricting it to only integers. Whereas in the list demo, I'm not restricting it to one particular type. Okay. But in case if you have a requirement that you are storing different types, in case if you have a requirement that you are storing different types and you want to ignore this warning, if you want to ignore this warning, then you can use something called @ annotation. That was ignored. But that warning is ignored only on the array list, not later.
Okay.
So in case you want to ignore it every time, you can put that. Otherwise, there was one more option there itself, where you want to add the annotation. Do you want the annotation on the array list or do you want the annotation on the main itself? When I say main, you get rid of mostly all of them. Okay, no, it's not happening, right? Yeah. Again here to uncheck. I think we got almost. So you add two different annotations. One is raw types annotations, you are asking it to ignore it, and you are also asking it to ignore the unchecked raw data type.
Okay.
And you don't see any warning now. It's completely clean now, right?
Okay. And one more thing, array list we can define only within the main method only?
No, you can also do it. If you look at our previous example of the bank assignment, do you remember which day I think this is a good day. If I open this bank with that Java, here you see here, you got a class, right?
Yeah.
You have an array, right? Personal customer array and commercial customer array. In the place of them, you can also declare. If you want to use array list, spelling mistake of the query. Yeah. Array list of what type? Personal customer type.
So here we need to give the parameter inside that array list.
Yes. Then you don't,
okay.
you don't see that warning messages called raw type warning messages.
Okay. No, even it's not the add method is not coming if we not give the any parameter like without the main method. If I say that in the customer class I try to initialize the array list with the customer name or something, but it gives the it's not giving the add method. When I say the customer dot add or something, it gives the error.
No, it will give you the add method, but it will give you the see. You see this stuff? Okay, you might have tried this, right? You did this like this.
Yeah.
And you might be doing this, right?
Yeah.
You might be using the personal customer object. I think you did this. Now you try to do this like this, right? You don't get add method here.
Yeah.
You cannot write.
Yeah.
You can only create objects in a class. Inside the class, you can create only objects. But if you want to write any logic, that should be inside a method. You cannot add in the main. You cannot add in the class. You should add only inside a method. See, you got this array list now. Now this array list. So this is a method called create personal customer. No.
Okay.
Now you get the add method. Inside the class, you can only declare variables and you can define methods. But if you want to perform any kind of logic, the logic can be performed only inside the methods, not outside the methods.
Okay.
Did I answer your question or was it something else?
Yeah. Now I got it. I think I had a method, but I'm not sure whether I write it the method or not. Now I got it, Arun. Thank you.
Right. Okay. All right. So what else? Okay. I was talking about the map in the last class, so I would like to continue from the point where I left. So there was a map demo, then I created a map object, whereas map stores the data in the form of key value. Map stores the data in the form of key values. Then you got a key, you got a value, you got a key, you got a value, you got a key, you got a value. Then there was a duplicate key. First, the 1002 was referring to Kalyan. Next, the 1002 was referring to Karan. So what happens? Let's see. Let's figure out. And if you see, 1001 is holding to Arun and 1004 is also holding to Arun. So let's see how it works. So the next big challenge was we learned how to store data into the map, and we also studied how to remove an element from a map. And I was trying to access the elements of the map. And let me print first what exactly this will give me. So I'm not simply writing map. If you observe, I'm not simply writing map. I'm writing map.keyset. Why? Because your map comprises of two columns. The first column is the key column. The second column is the value columns. So what exactly you are trying to do is you are using the map object to call the keyset method. You are using the map object to call the keyset method, and that gives you all the keys. So that gives you all the keys. So actually map.keySet, if you observe, what is the return type of this keySet method? The return type of the keySet method is set. How do we read data from the set? If you look at your last class example, how do you read data from the set? It's very simple one, right? After colon, you just write down the set name. So that's what I'm trying to do here. When I say map.keySet, that gives me the set. But what set it will give you? Map.keySet. Can you just give me a minute? Okay, I'm back. I'm sorry. Okay, and here we go. Map.keySet. So when I say map.keySet, what the map.keySet will give you? It gives us the set of keys. Set of keys. Now let me print it to see what is happening. You see there 1001, 1003, 1002, 1005, 1004. But is it the order I entered? No. I entered 1001, 1005, 1002, 1003, 1004. Right. So as we already know that the set doesn't guarantee the order. Your hash set is not ordered. So whatever the order you enter, you don't get it in the same order. Now you have a key, but are we interested in the key? We are also interested in the value. So what I do is, I print the key, then I give a space of tab, I give a tab space, focus here, map.get, and you pass the key. Now you run it. You see there 1001 Arun and 1003 Anu, 1002 Karan, but actually 1002 was Kalyan. But later what you try to do, you try to store one more instance of 1002, but it won't allow a duplicate key. What it does is, it is overridden the value of the 1002. It has overridden the value of the 1002. Then you see 1005 Kiran and you see 1004 Arun. So the values can be duplicates, keys cannot be duplicates. Keys cannot be duplicates, whereas values can be. Keys cannot be duplicates, whereas values can be. Now this was fine. So what did we learn from this activity was, we learned how to store data into a map, then how do we read data from a map. It's all good, right? So what's more, you learned, we spoke about the map, and I realized that it is not ordered. who is not ordered, hash map is not ordered. So what I do is I will pick up one more, that is instead of hash map I pick up linked hash map. Now I run the program to see the output. Now you see 1001, 5, 2, 3, 4. Look at the insertion. 1, 5, 2, 3, 4. You exactly, it's ordered. It's ordered. Then I discuss one more. You got a map, you got a hash map, you got a linked hash map. Now you have one more concept called tree map. Now you look at this. You see 1, 2, 3, 4, 5. It's natural order, that is ascending order. Perfect. Seems to be good. Now, what more in collection framework? In collection framework, you have two categories. One is collection interface, other one is the map interface. Now, what is the difference between the collection interface and map interface? Collection interface only holds values, whereas map interface, it holds in terms of keys and values. And there is a map, it's an interface, and there are implementations to it. Hash map, linked hash map, tree map, they are all implementations of it. Alright. And tree map is not the direct implementation. So there is something called sorted map. There is something called sorted map. So if you look at the hierarchy of the map, there is a map which lies. Then following the map, you have a map is being extended, or let's write this way. You got sorted map, which extends map. You got the other stuff like hash map, implements map, linked hash map, implements map, whereas your tree map implements what? Sorted map. Right. So let's see whether they are actually true or not. Is sorted map extending map, or is it something else? So if you look at this, I discussed in the last class, how do you find? There is a command prompt. Then you just need to set the path. Where did you got your Java installed? C drive, program files, Java, JDK, and a bin. Yes.
Arun, I had a question about the program that you showed on map.
Okay.
When you were using the for each loop, you used the method called map.keyset.
Yes.
And it returned a set.
Yes.
So I was wondering how the method keyset was returned so that we can assign a set into an integer object key.
We are not assigning a set into an integer object. If you observe this, what is happening? Here also it's an integer set, right?
Mm-hmm.
I just gone back to the previous day program. It's an integer set, right?
Mm-hmm.
And here I'm not using equal to. I'm not using assignment. I'm using a semicolon, right?
Okay.
So this is a set of integers. I'm just placing a set there. So since it is a loop, at a given point of time, it will read only one integer from a set,
Okay.
right?
Okay.
So it's an integer set, and at a given point of time, it reads only one integer and it prints it. Then when the next cycle comes, it reads another integer. Same
Okay.
thing happening here. Map.keyset. Okay, let me simplify this. This is gonna be something like this. Set integer map dot keyset. Then you write your for loops integer colon set. Is it simple now?
Yes.
Yeah.
And the map.keyset returns a set
Yes.
of integers, and we don't need to cast it or anything.
Okay, so map.keyset, it returns a set. It doesn't guarantee what type of set it is, because when I am creating a map, I said that what is my keys. While
Integer.
creating the map, I'm specifying the keys as integers, values as string, right? So that's the reason when I say map.keyset, it is returning an integer set, right?
Okay.
Because of that, it is not complaining. Now, while creating the map, when I say long, while creating the map, if I say long, you see a problem.
Okay.
Then I need to convert this. Of what type? Okay.
Okay.
Now, there is an advantage of this actually generics. This concept is called as generics concept. I'll tell you what is the advantage of using this. So what exactly happens here is, since you specified integer, you try to violate here. So at the time of compilation itself, it is checking, right? It is ensuring that whatever the data we entered is proper data. So that is the advantage of generics. So what generics will do is, at the time of compilation itself, it tries to figure it out what exactly you are trying to do is correct or not. Now imagine if you don't use generic. I'll just give you an example. Another example. I'm just creating a hash set, but I'm not using a generic. Okay. Now this was introduced in JDK 1.5, but your hash set was in JDK 1.4 only. Right. Your hash set was in JDK 1.4. Your generics was introduced in 1.5. Now I have a hash set. Now to this hash set, I am adding only integers. Because I know only I will be adding integers, because my requirement is such way that I will be adding only integers. Right. Now what I would like to do is, I would like to find the sum of all these numbers. I would like to find the sum of all these numbers. So let me take a variable called int sum is 0.
Aren't they supposed to be unique?
No, they can be different. Oh, right. Thanks. Because set don't allow duplicates.
Right.
And here, what you can do is, no, you cannot say integer. Why you cannot say integer? Because you didn't specify that. So when you don't specify, what is the default? It's a parent. Who is the parent of all the class in Java? Object is the parent of all the class in Java. Then from hash set you are reading it. But you don't know what is stored in the object, because while creating the object you didn't specify. So it can be an integer, it can be a float, it can be a string. But we are not sure, right? Alright, but what I want to do, I want to find the sum. But if I say something like this, it's going to work for me. It won't work. Then what I need to do, I need to typecast. Then it will work. Okay. But if somebody knowingly or unknowingly passed like this, is it complaining you at compile time? But at runtime it of course throws a complaint for you, because when it tries to convert that object to integer, there will be a problem. So this is the advantage of generics. Your generics, what they do is they ensure that whatever the data you enter while giving it as an input, you enter the proper data. And one more thing is, here you are doing a explicit typecasting, right? But here you don't need to do that. So as a programmer, you should not be worried about typecasting and all the stuff, because generics is taking care of.
Oh, okay.
Right? There is no explicit typecasting here. You directly, when you say map.keyset, you are getting integers only. You don't need to typecast. Whereas in this case, when you do map.keyset or when you say hash set, it is not returning you the set of integers. Though you stored integers, it is not returning the set of integers. It returns set of objects. But since we are the one who developed the program, so we know that I am going to get only set of integers. So I am converting that object to integer.
Right.
So the problem is, in case if somebody might have entered this knowingly or unknowingly, you are not letting them realizing their mistake. You are not making them realize the mistake, because hash set is a collection, and collection is a collection of different objects as well as similar objects. You will realize the problem only at runtime when you are trying to convert that object to integer. There will be a typecast exception.
Right.
So this problem can be avoided with the help of your generics.
Okay. Thank you, Arun.
Let's moving back. We are here, right? Map demo. What I was trying to demonstrate. I was trying to look at the profiles. Java P, java.util. What do we need to look at? Hash set. So if you observe, your hash set is implementing set, but it is also extending what? Abstract set. So it is implementing set interface. Hash set is implementing set interface. Similarly, you have your linked hash set. Your linked hash set is extending the hash set and implementing the set interface. Then you look at a tree set. I was trying to tell you that tree set extends set, right? So a tree set, what it is tree set? It's a class. Your tree set is implementing sorted set. But is it implementing sorted set? No. If you look at this, tree set is extending abstract set and implementing what? Navigable set. Now let's see what is navigable set. Your navigable set is extending your sorted set. So your tree map is not going to extend the map. Your tree map is going to extend the navigable. Your tree map is implementing sorted map. No. Your tree map is implementing the navigable map, and the navigable map extends sorted map, and that extends map. So it's all about this. Map is an interface, sorted map is an interface, navigable map is an interface. Whereas tree map is a class implementing navigable map. So same thing applies for your set also here. So what is your set doing there? Your navigable set extends sorted set, and that extends set. Your hash set implements set. Linker hash set also implements set. And your tree set implements navigable set. Right. And navigable set is extending sorted set. Then when it comes to your, you got your array list. Your array list extends list, sorry, array list implements list. And you got your linker list. Your linker list is much better. It is also implementing the list. It is also implementing the queue. Your linker list is also implementing the queue. And you got your vector, which also implements queue. I didn't speak about the vector. I'll come back to it after threading. And there are a lot of other things which I will be discussing. There are something called blocking queue, blocking DQ, transfer queue. These all things I will be coming across after threading. So after threading concept, again we will be coming back to this. Not only this, there is something called concurrent map. Again, these things also I'll be coming across. We'll be coming across after the threading concept. So we need to understand what is synchronization, then we understand these concepts better. The concurrent. Right. So what more now? So what more is, let me create a class, and let me call the class as a employee. Now in this employee class, I'll let you know what I am trying to do now. I have a ID, I have a name, I have a salary, and for everything I will go with a getter and setter method. Let me correct the mistake. Generate getters and setters. Right. So you got ID, name, salary, and you have a get method and setter methods. This was fine. Now I got a class, and I say sort employees, and I got a main method. I said sort employees and I got a main method. Then let me create some employee objects. I have an employee object 1. Then let me set the employee ID. Set ID. Set name. Set the salary. Then I have few more employee objects. I got employee 2, employee 3, employee 4. So what do I have? I have 4 different employees. Now let me change the names. Let's see where is the salaries to. Right. So you have 4 employee objects. Now what I am trying to do is I am creating an array list of employee type. I'm creating an array list of employee type and I'm adding all those employees to employee array. Employee 1, employee 2, employee 3, employee 4. Then let me display the details. You might be wondering what I am doing here. It's the same stuff, right? I'm just creating a employee object, storing into an array list, and I'm trying to displaying it. But you will understand the intention of doing this. So displaying the data of the employees, then I have a for loop. Employee list. Then I display the name, get the name, get name, get ID, get the salary. Perfect. You run the code, you see the output. All well. Again, let me go back to the previous day class, that is on day 12. Then let me go to this restricted list array demo. And if you go to the bottom, I want you guys to observe the line number 16. What is so special about the line number 16? So you have a utility called collections. It is not collection. Collection is an interface, but this is what? It's a class. Collections. You see the yes, letter yes there. Collections. It's a utility and it got a sort method which can sort the data. You see a utility, it got a sort method and it can sort the data. Okay. It can sort the data. Then after sorting, if you might have observed, you see the data in increasing order, 23, 34, 45, 55, 56, 66. Now, I would like to apply the same thing over here onto this sort employees. I'm using a utility called collections. It's a class. Then you see a sort method. Then I'm passing a employee list to it. Oh, why do you see a red color mark? The red color mark was not there earlier, right? You don't see the red color mark before in the last example. Then why do you see a red color mark now? Why a red color mark now? Why not in the previous example? Right. So this is something very important. One need to understand this. The reason being integer. Earlier it was an integer list. Earlier it was an integer list. So your JVM or your Java compiler, they knows how to sort integers. They know how to sort integers. I reiterate the point. In the previous example, collections.sort and the sort method was accepting integer list as an argument, and there was no compile time error and there was no runtime exception. The program was successful and we got the sorted data. But when I'm trying to pass employee list, it's giving me the compile time error, not even the exception at runtime. It is the compile time error itself. But why it is giving me the compile time error? The reason is your JVM and your Java compiler, both of them are aware how to sort integers. How to sort integers they know. Who knows? The compiler of Java and the JVM of Java. But what I am passing here, employee list, an object of types employee, array list of type employee. But your compiler know how to sort employees, or your compiler don't know how to sort employees. Your JVM has no clue how to sort employees. So that is the reason you got that compile time error message. But let's read out the error message carefully. Then you will understand that whatever the argument you pass here, means you are passing employee list, no? It's an array list of employees. So you see some solution over here in this error message. The generic method of the collection is not applicable. The input type employee, I want you guys to focus on this. The input type employee is not a valid substitute for the bounded parameter t extends comparable. That is, if you want to pass something over here, if you want to pass array list of employee, then your respective employee class must implement or your respective employee class must extend what? Comparator. Must extend what? Comparator. Sorry, it's not comparator, it's comparable. You see, comparable. So let's see the integer class. Java P Java dot util dot integer. Oh, what's wrong? Why Java? Oh, sorry. Your integer doesn't belong to util. It belongs to java.lang. So if you look at the profile of the integer, oh, your integer is extending what? Number. Your integer class is extending what? Number. And what it is implementing? Comparable. So your integer is a child of comparable. So that is the reason in the last class when you say collections.sort and integer list, it didn't complain because your respective integer class has already implemented the comparable interface. Respective integer class has already implemented the comparable interface and overridden there will be a method. What is that? Okay, yeah, look at this. int compare int int. So the integer class has implemented the comparable interface, has already implemented the comparable interface and overridden this method compare with int arguments. Compare with int arguments. So what you need to do is, you got your employee class, you should have your employee class implements comparable, alright, implements comparable, and when you say implements, you must override the method. I said add unimplemented method. So what is that method here? It's compare to, alright, okay, this is the compare to method, implements compare to method. Now what I do is, now here I'll be specifying what should be the criteria. So I will be saying here, you have one object, okay, you have one employee object, and there will be other one default, right? So I'll be saying here, what I need to say, okay, here you have one get ID minus o dot get ID. So you are, what are you doing here? You are subtracting the okay. If this is not, I have another solution. If it is greater than 0, return 1. If it is less than 0, sorry, if it, oh, okay. The difference is greater than 0, return 1. If the difference is less than 0, return -1. Otherwise, you return 0. So, what does it mean? The current object ID minus given object ID, if it is greater than 0, then employee ID of the current object is greater than the previous object. Then otherwise, next thing, current object ID is less than the given object ID, then current object ID is less than the given object ID, so it's -1. Otherwise, else return 0. That is, IDs are equal. So what are we trying to do is, you implemented comparable and you are telling here with the help of compare to method, we are letting everyone that we are, with the help of compare to method, we are letting everyone that two employee objects can be compared basing on ID. Now if you go back to sort employees, you don't see the red color mark because the employee class has implemented comparable interface. Now you can print the data, displaying the data of employees after sorting. Now you see the difference between both. In the first time you see whatever the order you entered, because you entered first what? Your first object was 1003, then 1001, 1002 and 1004. That's how you see there. 1003, 1001, 1002 and 1004. But if you look at the sorted data, you see 1001 ID first, then 1002, then 1003 and 1004. Right. Okay. Is this clear? The comparable, or any questions on this? Okay. Good. So you know how to sort employees, or how to sort list of employees using the sort method. How to sort list of employees using the sort method. Now, let me talk about this collections dot. You see here there is something called reverse, and I'm passing the employee list. Then I again display the data. Run this. So this collections is a utility. You get the data in reverse order, if you can see 4, 3, 2, 1. So this collections class is a utility. Now this is all fine. Now I have my next question. Now I sorted it basing on ID, right? Now I want to see the list of people basing on the salary. Now I want to see the list of people. Normally if you look at any of the web pages, or you will have a lot of options. Or you take your Microsoft Excel. Right? In the Microsoft Excel, if you look at this, you have a filter option. Then it will ask you here. So what you want to do? You want to sort it? Yeah, you want to sort it in increasing order, decreasing order. Now suppose this is my ID. Then this is my salary. It will tell me. So which I pick here? Oh, this. And if I go filter, oh, sort by ID. And if I pick salary, then it says sort by salary. So you have this option, right? So I want a similar kind of options here also. I also want a similar kind of options in here also, in Java. Now I can see the sort by employee ID, but I also want to see sort by salary. So I don't want to rewrite the logic here. I don't want to rewrite the logic, because if I override the logic, then only one will be there. Either sorting by ID will be there or sorting by salary will be there. But I want both. I also want this sorting by ID. Simultaneously, I also want sort by salary. So in that scenario, what you need to do is, you need to develop your own class. Again, a sort criteria. Right. So here I say, I'm creating a class. Just focus. Salary. Right. Sort by salary. This is my class name. Then here I will try to implement, I won't be saying comparable here. In this case I'll be going comparator. In this case I'll be going with comparator. Implements comparator, but what? Employee. Then I pick add unimplemented methods. Then you got a method called compare, but this time, last time it was compare to method. When you implement comparable, it's compare to method, which takes only one argument. But here I'm implementing comparator. It got a method that takes two arguments, not single argument. Now what do you want to do? I want to do it, sort it on the salary. So it's simple. Again, alright, get the salary of the first employee and also get the salary of the second employee, and find the difference If it is greater than 0, return 1. If it is less than 0, return -1. Else, return 0. But how do I use this? I go back to the sort employees. Look at this. Collections dot sort, but the sort method is taking two arguments. The first argument is the employee list. And what about your second argument? Second argument is gonna object of the salary, the sort by salary, the comparator object. Then I pass it. Then I print it again. I give a message. After sorting by salary. Look, 112, 123, 132, 14. So these things are handy actually. They come in handy, right? When you want to populate the data, in different formats, and these things are going to be helpful to you. Yes.
Arun, I was wondering, what if the employee class implements both the comparable and comparator interface? Would that work in this scenario?
Right? As you said. Now, you need to override a method. Right? You got one more method. So you write some logic over here, right?
Okay.
Now, after writing a logic some over here, okay, then so let's pick up that logic and put it over here. And there is nothing called O1 and O2. Perfect. Now here we go. Sort employee. Now what object we need to pass now here? Because your class itself has implemented, right?
Yes.
It's working, huh?
Right.
So
No,
it's
it's
gonna
not.
work for you. But thing is, you are actually the class is not that readable. You have two methods, right? And comparable and comparator. It works, but instead of if you create a separate class, you can create as many criteria as you want. If you make your employee implements comparator, then what you do? You write only one logic inside this, right? Now suppose I want to sort by name now. What are we gonna do?
Oh, okay.
Now this is by salary, perfect. If I want to sort by name, this will not be handy for me now, right?
Okay.
That's the reason. The default criteria, you use comparable. Use comparable and put the default criteria. And for other criteria, it's better you develop a separate classes. The way I develop it, sort by salary.
Okay.
Then you can also say one more class called sort by name. Then you can pass here while calling a sort method. You can pass whatever the argument you want to pass. You can pass sort by salary or you can pass sort by name.
Okay. Thank you.
So this was fine, okay, all about the sorting. Let's get on to the, we spoke about comparable and comparator. This is important too. Let's talk about a bit about the set also. Here we go. Again, I am coming back to the set. I don't know what did I name as sort employees. Okay. So let's talk about a duplicate employees, or restrict duplicate, restrict duplicate employees. Right. Yeah, let's go with the main method. So you got these employee objects. So what I do, I go sort by salary, not sort by salary, or sort employees. Yeah. I get all those 4 employee objects. I get all the 4 employee objects. Then I put it over here. Now I'll make a duplicate of this. When I say duplicate, it will be an employee 5 object, but your employee 5 and employee 4, they are having the same data. If you observe, employee 4 and employee 5, they are having the same data. Employee 4 and employee 5, they are sharing the same data. Now what do we need? What do we do now? We got 1, 2, 3, 4, 5. 4 and 5 are having the same data. But we know that set don't allow duplicates, right? Set don't allow the duplicates. So let's see. I'm adding all of them. One after the another. Add 1, then you got 2, 3, 4, 5. Then perfect. So how many objects I have? 5. But we know that set don't allow duplicates. So there should be only 4. What do you see? 1, 2, 3, 4, 5. Who is duplicated? 1004, right? If you observe, you see 1004 twice. Here, here. It is completely against the principle of the set, right? What is set? It should not allow duplicates. But if you look at here, if you observe this, it's actually allowing you the duplicates. So what? So your set is applicable, your set don't allow duplicates only for fundamental data types, not for the user defined data types. So what exactly is the problem over here? What exactly is the problem over here? So let's talk about the problem now. So let's go back to again Java profile. Just start looking at javap java.lang.integer. Now if you start looking at javap java.lang.integer, then somewhere you see 2 methods. One is equals method and other one is hash code method. Hash code method actually belongs to the object class. So let me show you the profile of it. And we know that object is the parent of all the classes. Right. Here you see there should be a hash code method for this. hash code method and equals method. And what happens is every class in Java extends object. Then they get a hash code method as well as equals method. And equals method will be overridden. And the hash code method, what is the significance of hash code? What is the significance of hash code? Hash code method uses or returns a unique value for every object. Hash code returns a unique value for every object. So hash code returns a unique value for every object. So there are 5 objects here. Object 1, object 2, object 3, object 4, object 5. So every time you use a new keyword, so a new hash code is generated. So your set that don't allow duplicates, set don't allow duplicates, and it checks for duplicates basing on hash ID, hash code. Set don't allow duplicates. It determines duplicates. It determines duplicates basing on hash code value. And every object will have a unique hash code. So there are 5 objects, there are 5 hash code values, 5 different hash code values. So what I try to do, if you see, I try to add employee 5 again. Now you don't see 6 objects. Add method is called 6 times. 1, 2, 3, 4, 5, 6. But you don't find 6 objects. You only find 5 objects. 1, 2, 3, 4, 5. Why? Because the hash code value of the employee 5 will be same. So it won't allow, because set don't allow duplicates. It determines duplicates basing on the hash code. But now, do I want the duplicates to be checked basing on the hash code? Do I want the duplicates to be checked basing on the hash code? No, I don't want the duplicates to be checked basing on the hash code. So what I do is in the employee.java, I'm going to do the right click, source, generate hash code and equals. Or instead, you can do one more thing. Right click, source, override or implement methods. What methods? Hash code and equals. Do you see hash code? Now what it is returning? Super.hash code. Now I just make it as return 0. So what exactly I'm doing is I'm just nullifying the logic. Alright. I'm making hash code ignored. I'm making this method ignored by returning the value 0 from it. Then what I do here is I will be writing everything inside this now. So tell me, on what basis you want to say that the 2 employees are equal or not? On what basis you want to say that both the employees are equal? If the employee ID of both the employees is same, then you say they are equal. Then now I'll be doing here is, first I need to convert that object to employee. Then here I'll be saying now, if get ID is equal to given employee.id, then return true, else return false. Now you see you find only 4 objects. Now you will find only 4 objects here. You got 1, 2, 3, 4. You don't see 5 because 5 and 4, they are sharing the same ID. 1, 2, 3, 4. 1004, 1002, 1001 and 1003. You don't see 1004 because what you did was you actually the regular definition of hash code is not getting executed. So every time you create a new employee object, the hash code is not something new. The hash code is always 0. Since hash code is always 0, it will depend on equals method for equality. Now what are you doing in the equals method? The given object ID is compared with the current object ID. If it is equal, you return true. Otherwise, you return false. Yeah. Is this clear for all or any questions on this part? The hash code and equals method. And it plays a major role actually in the collection hierarchy. And when someone talks about the collection framework, they're going to sure speak about this. Alright, then if no question, then let me move on to the next topic. There is something called as a queue. Right? A queue is an interface. So queue demo got a main method. So queue is an interface. I cannot create object of it. Queue of what type? Integer type. So when queue is an interface, you cannot create object. But what I can do is I can create object of the implementation. There's a linker list which implements queue. Then I create object. And if you see, you got an add method. So queue, right? From queue where the elements get added. Queue elements get added from the end. Queue elements get added from the end. But when it comes to removing, it gets removed from the beginning. So if you see you are adding, so what is the first element you added? 23, then 32, then 43, then 45. So 45 should be the last element. 23 should be the first element to go. So when I am trying to print it, what do you see? 23, 32, 43, 45. Right? So it is very simple one actually, right? There was nothing. It is similar to your linked list, right? Look at something called as a DQ. DQ stands for double-ended queue, and you see a lot of options here. You can add from both the ends and you can remove from both the ends. You can add from both the ends, you can remove from both the ends here. If you observe, you have something called add first, add last. So you have the option to add it from both the ends. Right? By default, it's add last. But when you say add last, it is from the end. And when you say add first, see, add integer. Insert the specified element into the queue represented by this DQ. Right? In other words, at the tail of the queue. So what is queue actually? You add elements at the end. So when you call the add method, it will add it at the end. But when you say add last, it adds at the end. And when you say add it first, it adds in the beginning. So you have the option in the D queue to add from both the ends, and you also add from the, sorry, in queue you can add only from the end. In do queue you can add from both the ends. And it's not only you can add from both the ends, you can also remove it from both the ends. Add first, add last. Then you can print it. "23 was added first. First you added 12, then you said 23 first and 34 last. So this is DQ. Then there is something called priority queue. See, these are all very simple things. The only thing I am discussing is to just make you that you people just know, aware of that there is a classes or there is a interfaces called Q and DQ. Otherwise, it's very simple. You just need to call the add method to add and you call the remove method to remove. The difference between the Q and the DQ is, in Q you can add only from one end and remove from, you can add from the end and you can remove from the beginning. Whereas DQ, you can add from both the ends, you can remove from both the ends. Now look at this priority queue. It's a class. And if you observe carefully, I'm creating an object. Then I'll be storing some numbers. You might be wondering it exactly works like a queue only. But when you see the output, you see the difference in the output. Priority queue. See the output of the last one, priority queue. You see it in the increasing order. Why you see it in the increasing order? Because the priority is ascending order. The priority is ascending order. So what you should do is, because we said 23, 13, 23, 24, 32, 36. But I never said that this is my priority. I never said that the lowest one should come first. The lowest value should come first. That is a default priority. So what we can do is we can violate this. I mean we can change the priorities. I'll be demonstrating how. I'm clearing the data from the priority queue. So after clearing the data, again I'm creating a new. I'm adding the elements. But observe here, this is what I want you to focus. While creating the object, you can specify the comparator. You can specify the comparator. Priority queue, this guy has some initial capacity. Why I need initial capacity? Let me use this. Initial capacity. Let's say initial capacity is 10. And I need to pass one object. So what I do is, let me create one criteria again. How do I do that? Okay. I do implementation of this new new comparator. Now this is anonymous implementation. While creating object, you are doing this. Comparator extends this guy. Okay, let's not go to the anonymous implementation. Let me create a class. Then I say descending order. I'll be going with implements comparator for integer. Then override the method. Then I will be doing the opposite. If O1 minus O2 greater than 0, I did earlier, right? If O1 minus O2 greater than 0, I return 1, but now I return minus 1. Now here, else if O1 minus O2 less than 0, I return 1, else if they are equal, I return 0. Now what I do here is, I'll pass that object. Perfect. Now my priority is what? Descending order. Now you see the data in the descending order. So this is how you can give the priority. So what is the default? The lowest value get the priority, right? But you can change it. How? By giving the priority here. Okay. The descending order is the priority now. Now I created a separate class, right? Descending order. I created a separate class called descending order, right? But instead what I can do is, I can do something called anonymous implementation. I can do something called anonymous implementation. Let me demonstrate that. Yeah. New priority queue, size 10, comma, new comparator. Now within this, I'll be writing that method. Let me pick this method from here. This is how we it was giving you the problem. I take the mouse over, then it says add an implemented method. Yeah. The t gets changes to integer. So this is what is anonymous implementation. That is, what do you mean by anonymous implementation? Is implementation at the point of use. Implementation at the point of use is called anonymous implementation. It's done. So you don't need to write a separate class. If you look at the previous one, you created a separate class and you create a separate class for descending order, then you pass that object here, right? What you can do is, for that interface only you can create object, right? And normally comparator is an interface. For interfaces, one cannot create object. But this anonymous implementation is possible. That is new interface, then bracket open, then within that you override whatever the method you need to override. This kind of implementations are anonymous implementations. There is an advantage. There is a disadvantage. If you write a separate class, you can use it any number of times. If you write a separate class like this, descending order, then you can use it as many times as you want. But if you use anonymous implementation, you can use it only once. Next time, you need to do it again. So this is the advantage, and there is also a flip side. You need it only once. You don't need it again. You go for anonymous implementation when you need it only once and you don't need it again. Go for this descending order, the separate class, when you need it again and again. Priority queue, here, anonymous implementation. Yep. Any questions on this part? The priority queue. So the default priority is the ascending order. That is the lowest value comes out first. And I change the priority to descending order. So while changing the priority, I have two ways. One is create a separate class and pass it as an argument. Create a separate comparator class, pass it as an argument. Otherwise, you can do anonymous implementation. Yep. Any questions on this? Okay. If no questions, we'll stop here. We'll continue in the next session. And in the next session, we'll talk about SQL. All right. Thanks everyone. Catch you in the next session. If you have no questions then. Thank you.